Okay, on your notes, please write down today's date, which is May 17th, I think. All right. On May 17th, write down binary. Okay, we're talking about the binary number system. It's the number system that computers use to talk, and it's a whole bunch of ones and zeros. There's no 2 up there, is there? Or 3 or 4. But by writing things in ones and zeros, you can write anything. In fact, the computer boils everything down to ones and zeros. Your name, when you type in, like say you're typing in John, it doesn't know how to write that other than a bunch of ones and zeros. And so it takes the J, converts it into a whole bunch of ones and zeros, and the O, etc. So everything, even pictures, all boils down to ones and zeros. Well, anyway, we're going to understand the binary system a lot better by the end of the hour. It's the language computers use. It counts by 2, not really. It's a base 2 system. And a lot of people have that misconception that it's like counting, by 2s. No. You're using 2s in the number system, though. When they were making computers, they could pretty much send electricity through these little things that you can consider a switch. And it would either, a little pulse of electricity would turn it on, and another little pulse would turn it off. So there's only 2 ways it could be. It could be either on or it could be off. Okay, that's base 2. Got 2 things it could be, either 0 or 1, either on or off. Okay, and there's those only 2 characters, the 0 and the 1, can make up everything. If you were going to put in, this is an ASCII 2 chart, by the way, and this is like what they use for the number for the letter A, for instance. Notice that a capital A is different than a small a. So if you type in a capital A, it knows, oh, well, you need number 41. And number 41 needs to get changed into binary. So this is all that idea that when you type in your name, you're getting a whole bunch of zeros and ones being put in. Now, to really understand binary, you have to understand our own system. And our own system is base 10. Why do you think it's base 10? Go back to the caveman. Sitting in the cave. It's got this nice collection of skulls in the back. Yeah, it's like 1, 2, 3. I mean, if we only had 4 fingers in each hand, well, technically we do if you're going to do the thumb thing. But anyway, let's say we only had 3 fingers in each hand. Okay, we like aliens. That they all have 3 fingers, of course, on each hand. Anyway, yeah, we'd probably be base 6. Seriously, it's probably that simple. There are lots of choices, and in fact, there are some ancient Aborigines, okay, living out in the outback, who would use base 2. They had a base 2 system. And the Morse code, have you heard of that? That's a base 2 system. Because it was either, the only 2 things you could discern were long or short. They were beeps. Like beep versus beep. And it's the only thing they could do differently. They couldn't like make it waver like beep. They could just either go beep or beep. It was just how long you held the beep noise. Okay, so do you guys know the international signal for distress? 3, it has to do with 3. 3 longs, 3 shorts, and just keep repeating it. And that stood for the letter S and the letter O, and then when you repeat the other one, it's a letter S again. And technically, you'd only have to do it those 3, S-O-S. Okay, it stood for Save Our Ship. And so it's longs and shorts. And if you ever had to send out a signal, you could send it with just taps. And it's the space between the taps that you'd have to vary then. So like if you're stuck in the, I don't know, the bottom of a building that's just collapsed in Haiti or something, and you need people to know that you're in trouble, as to separate it out from just like general noise, because yeah, you could just bang on something, but to separate it out from general noise, if you tapped out 3 longs and 3 shorts, they'd be able to tell that this was not something naturally occurring or just, it's the wind beating on something or whatever. Okay, so that's another example of base 2. But you really have to understand our own system. But our own system, you're so used to it, you don't even think about it. So in order to show you what I mean, you should, if I said, I know that as well as the back of my hand. Take a look at the back of your hand for a minute. That's from the movie, isn't it? There's a quote from a movie, the Robots, I think, has that in it. But anyway, if you just look at the back of your hand, like I never knew I had a hair sticking out right in the middle of the back of my hand, big black hair. I don't know. You might find something that's unusual about the back of your hand. Maybe you didn't notice that there was a little cut. I bet you a lot of you have a scar on the back of your hand. How many of you guys have a scar on the back of your hand? Well, that's a lot of you. All right. Any of you see a scar there that you cannot remember? Like, I don't remember what happened there. Yeah, several. Okay. And that's probably due to having it happen when you were a little kid. Or maybe it was just something that was so insignificant that didn't seem like a big deal at the time, but it left a scar. It doesn't have to be like, some guy with a great big dagger sticking in the back of your hand. It's more likely to be just a little scratch. It just doesn't heal right. I've got several. I've got this finger was broken badly in a football accident. I was going across the field, right in the middle of the field, and with my hands out trying to catch the ball. The ball had been thrown. I had my hands extended, and then the guy just ran into me just really hard at like not necessarily the full speed, but close. And my finger was extended straight out, and it just jammed it really hard. Okay, and if you've ever had a jammed finger, it hurts bad. But this was bad enough that I was, a tough guy, so just taped them together. Taped these two fingers together. See how they grew together nicely because the finger was actually broken. And so when I taped it together, it just, like it now formed perfectly to that finger. So anyway, moral of the story there is you probably should have mom do the quick, trip to the doctor to check it out. Because thankfully it healed right. If it hadn't, if they didn't have full range of motion, they probably would have had to go back in, use a hammer, break it again to be able to set it right so that they can like make it heal the right way. So anyway, I'm glad that it ended up healing okay. But yes. Mm-hmm. Oh, yours is bent the other way. Oh my gosh. Wild. Okay. That's just somebody just showing me his pinky goes the other way. Didn't like meld into the other finger. It kind of like gone off to the side. So maybe we shouldn't be trying to do our own doctoring. More moral of the story there. Okay, well, the point is that you look at the back of your hand, and you don't even notice that there are things there that you may have not noticed before. Well, if we're going to look closer at our number system, I know if we go back to the elementary school, you'll be able to tell me that 6 is in the ones place, right? And what's the 4 in? Tens place, etc. But really why that is because we're in base 10, so those are all 10 to the something. And that first one's the hardest one. A lot of people think our number system is based on 1 because of this, but it's not. It's based on 10. 10 to the 0 is that first spot, so that's why it's the ones place. 10 to the first is the tens, 10 to the second, the 100, and 10 to the third is the thousands place. Do you see where I'm going with this? If I say our system is based on 10, what's binary based on? 2. So instead of 10 to the second, it's going to be 2 to the second, 2 to the first, 2, get the idea? So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. That's what the binary system's based on. All right, so let's look at one more thing. I don't know if you noticed, but we're a base 10 system, and there's 10 little things you can write in here. A lot of people think there's 9, but they forget about the 0. There's 10 little digits that we can write in there. So if you're a base 2 system, how many little digits can you write in there? 2, either 0 or 1. That's why it's only zeros and ones. Okay. All right. So if we were going to change this to base 2, all those question marks would be different. And these could only be what's? Ones and zeros. So like 1, 0, 0, 1 or something like that. And these would all be 2 to the something. What's that first one got to be? 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And that's the same as 1, and that's 2 to the 1, which is 2, and 4, and 8. So if I had the number 1001, it would mean I'd have 1 8 and 1 1. So that would be 9.